Dr. N. Sivakumar, Assistant Professor, Department of Chemistry, Common Deputy University. Now we are going to discuss basic principle of organic chemistry. Organic chemistry dealing with carbon and hydrogen molecules, exception of nitrogen, oxygen, sulfur and phosphorus. The example of the salt of carbon dioxide, urea, thiourea, etc. Now the classification of organic compounds based on the cyclic or acyclic, the open chain or closed chain organic molecules. Open chain organic compounds nothing but linear or branched chain hydrocarbons. Example, carbon attached one more carbon or other carbon, the series of number of carbon and hydrogens. Here CH3, CH2, CH3 like this are based on the number of carbon and hydrogens. Take one example. Alkane is the common name of open chain organic molecules. Here CN, the general formula CnH2n plus 2 is an alkane. Say example, methane, ethane, propane, butane, pentane is the adding of number of carbon and hydrogen. This is based on the formula CnH2n plus 2 is an alkane. Here n equal to means this molecule open chain or ethane CH3. This is based on the n. Here substituted n equal to 3 means is a propane. Or substituted n equal 4 means butane, pentane like this hexane etc. going to increase of n number of carbon and hydrogens. Next going to closed hydrocarbon. Say example benzene. It is a benzene is a closed aromatic compound. Say it's having carbon alternative double bond of carbon and alternative double bond of carbon. 6 carbon are attached to this ring. It is called as a closed chain molecules of benzene. This closed chain benzene having two types. One is heterocyclic and another one is homocyclic. Here the benzene is attached to 6 carbon. Here is replace of 1 carbon is a example like I say nitrogen, oxygen, sulfur. The oxygen is a furan. The 6 member ring is a pyridine. The substituted P is here. The 6 member ring of aromatic closed chain molecule is a pyridine. And 5 member carbon replace of oxygen is a furan, thiourea. Like I say, these are all closed carbon molecules. The open chain organic compounds. This example of linear and the branched chain hydrocarbons. Going to based on the functional group. The classification of based on the functional group. The linear chain functional group is a ethanol is having the attached the carbon having the 4 different valency of carbon molecules. It's carbon directly attached to 4 different atoms. Example 3 hydrogen, 1 OH group. Here this hydrogen is a atom, single atom. OH is a functional group. This functional is a hydroxyl group. This CH3, OH is a methanol. CH2, CH3 is ethanol. Like I say, based on the increase the carbon. Next, the functional group is aldehyde. CH3, CHOH is a aldehyde. This is acetaldehyde, propanaldehyde, pentaldehyde. Like this is the aldehyde base series. Ether. CH3O, CH. This is a carbon direct attached to oxygen and one more direct attached to carbon. This is middle of oxygen is both sides of CH3 is a ether, dimethyl ether. Like I say, dimethyl ether, diethyl ether. Like I say, ether molecule. Next is the acid, carboxylic acid. CH3COH is acetic acid, propanolic acid, and furanic acid is based on the increase the carbon and the hydrogen molecules. These are the functional group of open chain molecules. It's aliphatic, aromatic and aliphatic compound. This is aliphatic functional group organic molecule. Next, move to the functional group of aromatic molecules. This is example of phenol. This is a good example of phenol. This is aromatic functional group OH. This is likewise alcohol molecules. The aromatic alcohol. Next, aromatic aldehyde. This is a different functional group. This is a benzene. We attach direct attached to aldehyde group and trinitro-toluene. These are all two different functional groups attached in the aromatic compounds. This aromatic compounds have two types. One is a non-aromatic or aromatic compounds. This is based on the occult principles. This is 4n plus 2 5 electron is the aromatic molecule. Does not obey the occult principles called as a non-aromatic compounds. Next, move to the classification of different type of molecules. They based on the functional group. This is having the negative electrophilic reaction, substitution reaction, S1 reaction, SN2 reactions, and functional group transformation, different type of carbon opening molecules and carbon closing and new carbon carbon bond forming reaction like SJ. These are all aromatic different functional groups present in the molecules. Open chain hydrocarbons. This is based on the bond order. The single bond hydrocarbon example, say linear structure or branched chain. A double bond structure. This is alkene is based on the I percent is alkene. It's a different CH3, CH2, double bond CH2, single bond CH is a alkene molecules. Let's move to the based on the triple bond. Triple bond order. Say acetylene, CH, triple bond CH. These are all based on the bond order only. Then the functional group is attached with the bond order, vinyl chloride, vinyl alcohol, vinyl propyl alcohol. These are based on the attaching with the double bond and triple bond molecules. The organic molecules dealing with only for the chemical properties of based on the functional molecules only. That's all for today. Thank you.